Hello everyone, my name is Hao and this is my first video on YouTube. And I'd like to help you guys with the VCE for the subject, for the math method, special math, and physics. Okay, and I kind of have like 4 years experience about tutoring these things. And now I want to create my own YouTube video channels to share with some tips with you guys. And today we're going to cover something about math method. Okay, let's look at the page 1. First, the function, and it's chapter 1 stuff. Okay, today I think we're going to cover 1A and 1B as well, just some basic math. So the first important thing is set. Basically, what do we mean by set? So set is just means by like the session or something you collect all of them together. Okay, so let's imagine set is your school bag. So inside your school bag, you got your lunchbox, you got your pencil box, and you also got your like books or computers. So all of this, we call it elements, and it's inside this set. Okay, and now we have to remember some like math symbols. First one, we call it belongs to, which is look like this one. Okay, we highlight over here. So if X is an element of A, so basically X belongs to A, or we say X is a member of the set A. Okay. And if, let's say, X is not an element of A, so we just cross it, okay, just like this. So it means X does not belong to A, okay? And since this one is connecting element and set, and we have another symbol to connect set with set, so which is this guy. And we call the name is subset. So for example, if one of the set is A equals 1 and 2, and B is equals to 1, 2, 3, so then we say A is subset of B, and we write like this, okay? For example, if we look at the book, our A is pretty big because it's 0, 1, 2, 3, 4, which is outside one. And the B is 0, 1, 2, which is inside the small circle. So you know the B is over here, so A is on the top or cover all of the B. So we call it B is contained in A. So in another word, B is a subset of A, okay? So this is pretty straightforward. And another two really important simple or mathematical expression to connect two set. The first one is intersection, which is looks like this guy. And another one is over here, we call it union. So the first one, the intersection, it means this element must belongs to A and belongs to B as well, okay? So it means by intersection, and also A intersection with B still is a set. So for example, we make over here, use this one example, cross over here. So it's A intersection B must be 0, 1, 2, okay? We never can write things like this. This is wrong. I'm sorry, but it's wrong. Because if without the big brackets or without brackets, it means they are just elements. So if you want to represent them into a set, you have to use this, okay? Now we can give us red tick, okay? And another thing is if we say two sets, they have no single element in common, nothing in common. Then we give another name. We call it disjoint. So basically A is over here and my B is over here. And we call it disjoint, okay? And of course, if we doing this way, if A, we try to find the intersection with B, you're gonna say, oh, we have nothing here. So how do we represent the situation here? We use another symbol, we call it empty set. So basically 0 with a line, okay? We call it empty set. And again, I think everyone is really familiar with this type of diagram. Okay, we call it Venn diagram, so which is pretty useful. And in you guys year 11, you already did a lot. So this, for this part, it's more like the revision. Okay, let's keep going. So, okay, sorry. Let's keep doing. For example 1, over here, we look at for A is 1, 2, 3, 7, and for B is 3, 4, 5, 6, 7. And we'd like to find A intersection with B and A union B, okay? So A intersection B is, of course, 3 and 7. They are only two elements in common. And if we want to find the A union B, it means 1, 2, 3, 4, 5, 6, 7. Then you can ask, come on, we have two threes. Why don't we just write 1? Because it's the basic rule for our set. We never repeat in our set, okay? If we have two threes, we only write 1 3 down, okay? If we have two sevens, we only write 1 7. Same thing apply here, okay? So no repeated element, okay? And for page 3, there's another really important symbol, which is over here, okay? We call it set difference. So it means the element contains in A, but not contains in B, okay? So this one is pretty useful. Later, I can show you guys why. And now let's move on to the next one. We call it set of numbers, okay? This is also straightforward. The first one is n, we call it natural numbers. And next one we call integers, which we simple as z over here. And rational numbers, we give its name as q, okay? And later it's irrational. Actually, we don't have any symbol for this one, but we can use r. We don't want q. So we use this one to represent the irrational numbers, okay? And the final, the really big one, real number is r. And some smart kids or some kids who learn specialist math, they're gonna say, sir, is this one gonna be bigger? I draw over here, okay? Make it C, which means complex number. But the good thing is, in math method, we didn't really cover. So for my following videos, if I did for special math, I will talk about the complex number for you guys, okay? And the relationship between these four sets is N is subset of Z, Z is subset of Q, Q is subset of R, okay? Hope that makes sense. And let's move on to another page, which is over here, the interval notation, okay? This is pretty important because in 2016, the final exam report, the examiner read the report says that a lot of students cannot really distinguish the difference between square brackets and small brackets. But I'm sure now everyone is pretty confident, but still it's really worth to mention that for the small brackets, okay, small brackets, it means greater than or less to, okay? So no equal sign. And for the square brackets, which is over here, it means x is less than or equal to b. Okay? And another thing is for positive infinite or negative infinity. Sorry, positive or negative infinity. So both for them is small brackets. Okay? For them are small brackets. And next thing is some people, or I mean some exercise, they ask us to illustrate of the following intervals on the number lines. So for the general rule is, if we can take the equal sign, which means it's square brackets, we put dot, okay? We put dot over here. If it's not, we put the small empty circle on it, okay? So in this case, which means the x value is greater than -3, but less than or equal to 4, okay? Now I'm gonna show you some really good way to write some set. So some people are gonna say that, okay, I like to represent this one, 0 to positive infinity, okay? So it means this is our number line, 0, 1, 2, 3. So we keep going. And this one 0 over here, so we keep drawing, okay? And we also can find another equivalent form for this one. Some people are gonna say, okay, so I know this one is R positive, but we have to remember R positive means 0 to infinity, but not include 0. So if we want to make this two equal, you have to use this one, okay? Union 0. Then these two sets are equal to each other, okay? So same thing. If I want negative infinity to 0 and square brackets, and we can write it's R negative union 0. Okay, make sure you guys know this one. Otherwise, I'm suggesting you guys in the final exam or in your SAC, you still doing this interval notations, okay, instead of these two. Okay, hopefully that one makes sense. And let's keep going. This is all the information for 1A. And let's move on to 1B. 1B basically gave us the ideas of what a function. And function basically means relation or like ordered pairs. Okay, so every time I give you an input, then you need to give me an output. So over here, every time I give you the x, then my processor is fx, and you give me an output, we make it as y. So this one, we call it function. So for example, my fx is x plus 1. So every time you give me the one value, I can give you another one. So let's say my x equals 10. So our output is 11. That is function. So give me an input, then you can get an output. And now we try to give them a fancy name, okay? For the all x values we can take, we give the one fancy name for it, is domain, D-O-M-A-I-N. And for the all corresponding output values, we give another name, a fancy name, okay? It's range. So technically speaking, domain and range are our mathematical terminologies. So for the following videos or for every videos, I will emphasize the math terminology to you guys. And another really good thing for this book is they highlight or they bold the important words for us. So you can always refer to the bold word and try to know its meaning, okay? So let's keep going. So for next one, they ask us to sketch the graph for the following relation and state the domain and range. For this part, is quite straightforward. So we have to know what the graph is and draw it, and to know what's the x value and what is the y value. But the really emphasizing point here is part C, is this guy. The part C is actually is a function, but it's discrete. Discrete means they're not continuous, they just a random dot over here, right? So for the domain, they can only take some certain values. In this case, it's -2, -1, 0, and 1. And corresponding range is just like -1 and 1, no other choice, okay? Based on the data they gave us, okay? Hopefully that one makes sense. And another one is finally, we define is what is meant by functions, okay? I know most of teachers are gonna tell you guys, okay, do the vertical line test. Then if it's one-to-one, do the horizontal line test. So in here, I'm gonna summarize for you guys, and hopefully that help you remember what is meant by function and what is meant by one-to-one function, okay? So let's do this one. So first, we got something we called relation. Okay, relation. Relation, then we got 4 relations. So 1x, 1y. So we call it one-to-one, okay? Then many x, 1y. In this relation, we call it many to one, okay? And then 1x and many 1. So we call it one-to-many. And the last one, we call it many x, many y. We call it many to many. So give you example, 1x, 1y, okay, comma, y equal x plus 1. Many x, 1y, I call it y equals x squared. So 1x, many y, I can give you x equal y squared. And many x, many y, I give you x squared plus y squared equals 1. Okay? So for the first two, for over here, this guy, they are function. Okay? Why? Because we only can have many x or 1x to 1y. And this one is corresponding to, over here, vertical line test. Okay? So vertical line test is going to tell us if this one is function or not. And the horizontal line test just going to tell us if this function is one-to-one function. The point here is because links to the next really important concept is inverse function. So that's why we need to emphasize here why it's one-to-one is important, okay? But it's going to be more introduced in the following videos. And let's move on to next page. For this part, I just want to emphasize here, you just need to substitute the value. So fx equal 2x squared plus x, you just add 3 in and do the basic calculation to get the answer. So which is 2 times 3 squared plus 3. So the final answer is 21. And the tricky part is here. So they ask us to do the f x minus 1. So basically, we replace the x with x minus 1, okay, to get the answer. And again, another point is just remember how to use CAS, because this one is pretty important during your final year exam. And for exam 2, it's 80 marks, or 2 answered for your final year marks are contributed by the calculators or the CAS. So you have to know how to define the functions, how to solve the functions, and later how to do the derivative or do the integration by CAS. Okay, also by hand as well. And the next one, they just emphasize the restriction of the function. So basically, they're not taking all the domain, they just take the part of it, and then we got some weird shape or the part of the shape. It's really depend on the question gives us, okay? And in here, for 1B, the last point I want to emphasize, which is pretty important, is this one, this notation. So page 12, example 9. In your final year exam, okay, your function normally gives us in this way. So it's f, and this way, this arrow r, comma, fx equals this one. So for these two underlines is the important part, okay? I'm saying it again. For these two underlines are the important part because this one always give you the domain, which means the x values. And this one always gives the relations, which means the equation you have. For instance, here is 2x minus 4. So if you ignore the domain, your graph gonna be beyond the required range. So technically no restriction, but actually we really want this restriction, okay? And I think this type of question occurs in 2017, the final exam 1. They ask us to draw the polynomial, and actually it's restricted the domain. So for that 4 marks, a lot of students, they missed because of misreading or because they don't understand this expression, okay? So for this class, you have to remember this one. Before the arrow and r, they always gave us domain. And the arrow to r, this r never means range. The r just means the y values is inside the r, inside the real numbers, okay? It's never the range. In this case, actually the range is -8 to 4, okay? Which is writing over here, okay? Oops, sorry. Just clean this one and let's keep going. Okay, this is the part I want to cover for today's short videos, and hopefully it's helpful. And if you guys like, please subscribe and click like button, and also write any comment if you want me to cover any more topics related to the math method or special math or physics or even like further math. Okay, thanks.